back, everyone, to our next topic, optimizing load connection times. So we're now on the chapter or the topic where we need to optimize the restaurants. We don't need to worry about security anymore. We need to optimize how we serve our customer, and we need to do it quickly and economically to serve both us and the customer. Now, the first topic is optimizing connection times. Basically, the physical nature of internet requires the server to be near them. So that's why we have this graph earlier or in the previous video. Now, when the customer requests to content delivery network, which is what we will use to optimize it or to make the search faster, uh, the server, origin server, did do not respond, but instead save the files or frequently requested files in content delivery network. So this is a graph of CDN cache. Now there are different other details to do this CDN. Usually we do that using server side cache. But I want to show you this graph, which is how the normal website works. First, the client requests to a web server and then it requests a database query. So instead of checking the database first, it checked first the cache, the server side cache, if that data is available there. So, so to process an HTTP request, a web server may in turn need to request other services. The this web server may need to request other services. So in order to configure that in your web server, we have what we call time to live. So that is the time where the stored data in that CDN or server side cache. I don't want to say or because it's not the same, but just to make things clear, you can save that in a server near the customer area so that you won't do a lot of requests or huge energy requests. So here an example of next topic would be optimizing images. Now images make the bulk of our websites. Here's an example of that. If you go to developer tools on this website, you're gonna see that the JPEG has 91.1 kilobyte, more than most of the files on the web page. And you'll see the time as well. Now, how do we optimize image on our website? First, we use the correct image format, which we've discussed in the previous chapters. The If you want to make the picture colorful, we use the JPG. If you want an animated, we don't need as much colors. We use GIF. Now, the combination of GIF and JPG picture is PNG. So I would recommend you go back to that chapter. So exporting for images for the web. One example of exporting image is Adobe. So we people could use Adobe to minimize their pictures. So before they use that on the website, they may choose how that image would be used on the website, whether it's high quality, medium quality, or low quality, depending on the use case. Usually, you just need medium to low quality for your small web apps, but for a large web application where quality enormously impact the scale or the application, you would use high quality. So here, in this Adobe example, we reduce the size by tenfold. So imagine guys, that 96 or 91.1 kilobyte will be 9 kilobytes. So that's uh, another way to make our web page or website optimized. Another technique to optimize images is explicitly specifying the size of image. So here an example of specifying the size. Here you specify the width and height on the HTML code. And then next topic is using a client-side cache. Before the client, or more precisely the browser, then makes HTTP request to the web server, it first checks the local cache to see if the requested data is already available. Here, instead of the web server, we optimize the website using local browser cache. Using server-side caching makes sense, for example, for data that really change, such as logos, static background images, CSS code, and JavaScript files. However, for content that changes frequently, such as articles, it doesn't make much sense. So another thing is for most website, images is actually consist or make bulk of the files there. So the optimizing image using the compression uh, will enormously make your website faster. So we have different techniques on caching via client side. First is caching via a header. So here is an example of that. A header, we use cache control max age equal this 315 6,000. So we configure this on the server side so that client will store that in their local cache. So browser can cache data by default. For this purpose, you can set cache control header when sending HTTP response. This header is then automatically evaluated by browsers, and the HTTP response is stored in the local browser cache according to specification defined in the header. And then another technique is caching via JavaScript. Furthermore, you can implement additional client-side cache logic within a web page itself using JavaScript and various web application programming interfaces. For example, you could store frequently used data locally in the local storage. So here, an example of storing uh, username and the value in a local storage. And here is an example of storing it in browser database, which is IndexedDB. So you can see that in browser developer tools in application side. And then third way we could cache via client is by combining server-side caching. So you may think that you can only cache in server side, you can actually combine both. So you can combine all these techniques depending on your resources or effort because it takes a lot of time as well to configure this. So it depends on your goals, whether you're working on a small app or on a big app. Caching can therefore be used in both server-side and in addition, of course, you can also run server-side and client-side caching in parallel as shown in illustration. Here, you can combine local browser page, server-side cache. I just want to add, you can add optimizing images via specifying it in HTML, compressing it, etc., or and using the correct format. Minifying the code. So you might think that the indentation, variables, constants on all the techniques to make your code readable is useful, but in this case, it's not as useful. So here's where minifying code comes because indentations, meaningful variable names, and explanatory comments should be used for clarity. However, in the production version of a web page, these tools should be avoided because every space, comment, and long variable name affects the file size of HTML, CSS, or JavaScript file. For example, since these files have to be transferred from the server client to the file size in turn affects the transfer time and thus the load time of a web page. So basically, optimizing needs to be balanced with security, like what I've said in the previous video, because optimizing often means that you need to balance it with security, which connected to our topic later, which is I forgot how to pronounce it, obfuscation. Because in obfuscation, what we're doing is the opposite. We're trying to make the code less readable so that hackers won't be able to spy us. So for this purpose, you can use various tools called minifiers, of which there are now variants for each of three major languages of web: HTML, CSS, and JavaScript. In this section, I'll use an example to demonstrate how to minify JavaScript files with Uglify.js minifier. So we'll provide an example on how to do that here. npx uglify -js main.js. So this is the command you would use to call that Uglify JS minifier. So if you already have Node.js on your development environment, you can just type this. In this case, the main.js file listing as shown here, we can minify this code further. Not further actually, because we haven't minified it, but we can minify it to make it to 498 bytes. So this is currently 714 bytes. When we use amplify that command npx-js here, it will become 498 bytes. So in this case, it's used as input and the minified code is written to the min.js. So in this first compression or minified code, the spaces, line breaks, and comments have been completely removed. So here's an example for that here, a minified JavaScript file. And then second, a step further, additional compressions can be activated via dash compress parameter as in the following command. So here is the second example. npx uglify-js dash compress dash o main dot min dot one dot js. And here's what it looks like. It's 476 bytes. So this code has been optimized even further. The variable and constant declarations were combined. So here, the variable and constants were combined. And then at the next compression tool or minifying tool, I don't want to say compression because that's different, but in a way you're trying to compress it. If that still isn't enough, you can switch on other optimization measures via the additional dash dash mangle parameter. For example, variable names and parameter names are shortened or simply replaced by shorter names by the following command. Here's the command: npx uglify-js dash dash compress dash dash mangle o main dot min to .js. So I know guys you're kind of confused on how this technical is. So could be complicated. So I prepared a metaphor. So a server side cache, it's like popular prepping popular dishes in advance. So some dishes are so popular that you would make them ahead of time. So when an order comes in, the chef checks the drawer first to see if the dish is already prepared. If it is, it's served instantly. Because remember, guys, we're trying to optimize economically or efficiently how we serve our customer to add value. Of course, we want to make it faster because we have limited time. And then optimizing image is like slicing ingredients the right way. Images are like the final garnish on a plate. If they're too big or in the wrong format, it's like serving a full roast on every plate, even if the customer just wanted a salad. So instead of sending a big plate every time, you choose the right size for the right meal. That is like optimizing image. Client side cache, it's like letting regular customers store their favorites. Some customers come in daily. So it's like having a mini fridge on the restaurant that has the frequently ordered meal by your regular customer. So instead of making them, you store that on the fridge and then let them microwave it. It's like a pre-cooked meal in 7-Eleven or other convenience store. So it's efficient. We're making it efficient. Minifying code is like removing the kitchen clutter before opening hours. So before the opening for the day, the kitchen is full of clutter, ingredients, labels, recipe notes, full ingredient names. To streamline operation and speed up service, everything gets cleaned up. The kitchen stop removes unnecessary details and shorten ingredients names to make the process smoother. So that's minification. It's cleaning up the kitchen to run efficiently during service. And then combining server and client cache, having both the warning drawer and personal fridge. It's like preparing it on hand and then a personal fridge for the customer. So it's efficient dual storage system for quicker service. Excuse me. So in the third part here, so you can see we make it even lesser. As you can see, it's 444 bytes. Now the reason for this is that the name, color, and age parameters of the construction function has been replaced by names O, T, and I. And then on obfuscation, you need to decide to each individual case whether the performance of the web page or making your source text unrecognizable is more important to you. So guys, here you would see that here's an example of that. For example, on my blogging app, you would see the code when you go to developer tools. When you go to source, you'll see my code here, assets. So it's not as secure because you'll see the source code. As you can see, I have node modules. This is my SRC, content scripts. So that's the nature of JavaScript because it's an interpreted language, meaning that it's not converted to machine language when running to a browser because the browser is the one running it. Remember our topic with interpreted and compiled programming language. And then compressing files. Besides the basic optimization of image and the minification of source code, you can push compression further by packaging the files on the server side in the gzip format. So here is the graph of that. The server even further compress it. So compression is like packaging these dishes for faster delivery. So you may not notice that um, restaurants provide storage box that is efficient in delivery so that it won't get spilled, etc. So this is it. It's like compressing it in the server side in GZIP format to be able to serve it more efficiently. And then lazy loading. And next topic is lazy loading. Loading data only when needed. So let's see the example for that. Here, the visible area, the viewport, resources that were loaded via lazy loading. So this is the best way to explain it is via graph, is that aside from minifying it, you load it only when it's really needed, when the customer browses into it. For example, instead of loading all 100 products in a search, including the images on the web page of an online store, the images are only loaded gradually. For example, when the user scrolls down to the search result as shown in illustration. And then next topic is preloading data. So is the basic setup of preloading data. Here you have DNS lookup first, and then pre-connect, the socket connect, and then prefetch, the actual HTTP request happen. So it's not after the HTTP DNS lookup and the pre-connect happen that the browser send an HTTP request in the background. So I want you to realize that, guys. So here we have in this process of DNS lookup, we have another different ways to further optimize our website. So we'll start with the first DNS prefetch. So using a DNS prefetch, you can tell the browser that for a certain URL, it should perform DNS resolution for this URL. If this URL is then actually retrieved by the user, the DNS resolution is omitted at this point, although we should honestly mention that DNS calls usually account for the smallest part of the total load time of a web page. As you can see, it's only 0.05 seconds. Second. I don't second, yeah. It's not seconds. So 0.05, it's like millisecond. Here, we can optimize this using this link. Uh, we can put a link and then equals to value DNS prefetch and then our server. And then here, pre-connect. So here's we're now on the second step, the pre-connect. So instead of DNS lookup, we reconnect the TCP handshake or TLS handshake for secure connection. Here we put the value of rel as pre-connect and then our href equals to our server. So a pre-connect goes one step further than a DNS prefetch. In this case, the browser additionally establishes a connection to the web server. For instance, the browser executes a connect and, in this context, a TCP handshake and, if necessary, transport layer protocol. So what happens is that when you're defining this, it the browser, instead of making time to know how it would connect it via DNS lookup and pre-connect, it automatically knows what it will need to do because you specify that in the back end. So it less thinking for the browser. So that's another way to think about this. And then next way is prefetch, which is on this part of the graph here, prefetch. Uh, you can use a prefetch to ensure that the browser, after it has performed a DNS prefetch and a pre-connect, preloads the specified server resource completely into the local browser cache, as shown in this figure. So here's the pre-connect, here is the prefetch. So prefetch basically allows you to load a specific resources that image.jpg that will be loaded by the browser. So remember we have forward slash that allows the browser to know the main or the main page of our web application or website. It loads that by default. In here, for that pre-page part of the for the for that prefetch part of the request, you automatically load that on the specific resources, so it's less thinking for the browser. Another related topic is sub-resource. It's almost the same as prefetch, but with the fetch, the browser decides with which priority it preloads the specified resource. In contrast, you can use sub-resource to tell the browser that a resource is a high priority resource. For this purpose, you'll need, you'll need to set the value of the rare attribute to sub-resource. So instead of because you might have multiple web pages that have different configuration for this. One web page has a value of prefetch. So if you have multiple prefetch, what you would do to set the browser the priority is a sub-resource. You can specify the top priority prefetch using sub-resource. So here's the graph for that. I don't know you guys if you're seeing this. So it's in the third part of that. It puts that in the browser cache immediately. And then pre-render, the last part. From a performance uh, point of view, the most complex type of preloading is called pre-rendering. In this context, the resource, as the name suggests, is loaded completely and rendered by the browser in the background. Rendering, in turn, involves downloading other resources such as images, CSS files, and JavaScript files, as shown in this. So this is a pre-rendered example. You pre-render a combination of files such as HTML, CSS, and JavaScript, not just resource. So here is the rel value pre-render. So when we go to the graph, here is the last part, which is the highest impact when we think about the load time because it is the longest part. It's about downloading the contents of your web app. So again, guys, we're done with optimizing part finally. And then on the next topic, we will tackle organizing web projects. So we will dig into the tools on how we actually manage web project in a real world. So we will use the most used decentralized version control system that will allow us to push our code in agile environment. So you will learn agile as well, which basically is a way of doing web application that is more efficient instead of thinking about all the details of web application. You do it iteratively. So it's based on feedbacks, which is great. So we were able to discuss optimizing images, optimizing load times, preloading data, which is the first part of loading our website, server side cache, client side cache, that will help us to make the app more efficient and put in the first search engine results. And again, guys, thank you so much for watching this and have a great day. Peace.